Hello everyone. In today's lesson, we're going to be talking about independent and dependent events. In this first video, we're going to be focusing on independent events, in particular determining whether events are independent. So at first, for just a definition, independent events is when the occurrence of one event does not affect the occurrence of the other event. So for example, flipping a coin and landing on heads or tails. If I flip a coin and land on heads, the next time I flip the coin, it can still just land on heads or tails. Me landing on heads the first time does not affect what it's going to land on the second time. And that means these are independent events. And we can find the probability of independent events by multiplying the probability of event A times the probability of event B. So if A and B are independent events, to find the probability of both of them occurring, you're just going to take the probabilities of the individuals and multiply them together. So for this first set of examples, we're just going to look and determine whether events are independent. So number one, a student taking a quiz randomly guesses the answers to 4 true-false questions. Use the sample space to determine whether guessing question 1 correctly and guessing question 2 correctly are independent events. So we're going to do back to what we did in some previous lessons where we're going to find the sample space and we're going to find the probability of correct on question 1, correct on question 2, correct on question 1 and question 2. And then I'm going to use this equation up here to see if it ends up being true. So first, we did a problem similar to this and we already made a sample space. So we'll go ahead and just make it again. So we're answering questions to 4 true-false questions. So the possible things that can happen when a student is randomly guessing is they can get none of them correct. So first, let's just make a table. So they can get 0 correct, so that means just all of them are incorrect. So I'm going to have I equals incorrect. C is equal to correct. They could get 1 correct. And so that means either the first one's correct, the second one's correct, third one is correct, or the fourth one is correct. Another thing that can happen is they can get 2 correct. And so those possibilities are this, I, C, 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 and that. They could get 3 correct, so that means the first could be incorrect, the second, third, fourth, or they could get all 4 correct. So let's find all of these individual probabilities. So the probability of getting 1 correctly. So question 1 correct. I'm going to look for all the ones where question 1 is correct. So I see that one, the C is first, 2, 3, 4, 5, 6, 7, 8 of these outcomes where the first one is correct. And if I add up the number of outcomes in total, there are 16. So it means that there is 1/2 chance of getting question 1 correct. Probability of getting question 2 correct. Let me erase all of these markings. So you have 1, 2, 3, 4, 5, 6, 7, 8 there as well. It's a 1/2 chance. And I want to see probability of getting question 1 and question 2 correct based on my number of outcomes here. And so looking here to see which ones I had question 1 and question 2 correct. So you have 1, 2, 3, 4. So 4 out of 16, which is 1/4. So now I want to see whether if I multiply the first two probabilities, I get my third probability. So when I do 1/2 times 1/2, I get 1/4, which is equal to that third probability. So that means that these are independent. Okay, let's try another one. So here it says a group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. So first I need to make a sample space. So I'm going to make a table, and I'm going to have number of girls, since that's the probability I'm trying to find, and then my possible outcomes. So I'm going to use B for boy, and then I'm going to use G for girl, but then I'm going to have a subscript for whether it's the first girl, second girl, or third girl. And so if there's one girl, I could have that it's girl number 1 and then boy, or I could have the boy chosen first and then girl number 1. And then I can have the same thing but with girl 2 and girl 3. So I have girl 2 and then boy, or boy, then girl 2, girl 3, then boy, boy, and girl 3. Another thing that can happen when selecting 2 students is that they can both be girls. And so I'm going to have 3 different options again for those. So I can first have that girl 1 is chosen and then girl 2, or that reversed, girl 1, girl 3, or that reversed, and then girl 2, girl 3, or that reversed. So I want to determine whether it's independent selecting a girl first and selecting a girl second. So I'm going to find first the probability of choosing a girl first. So the number where the girl is chosen first is 3 for when there's only one girl, and then all of the seconds, so it's going to be a total of 9. And the number of outcomes in total is 12. And when you simplify that, you get 3/4. Then I want to find the probability of the girl second. And I find that's going to be the same thing. Then I want to find the probability of girl first and second. And I see it's going to be all of these 2 girl rows here, and that is in total 6, which is 1/2. So now I want to see if the first 2 probabilities, if I multiply them, I get the third one. So when I do 3/4 times 3/4, I get 9/16, which is not equal to 1/2. So that means that this is not independent.